Good evening, my name is Maggie Bick and I'm the CEO of our Tiger Tech company here at Thomasville High School. To let you know what we're doing this year, we are invested in a competition called Best Robotics. Each year they find a cause that needs some kind of mechanical engineering, all of the best boosting engineering, science, and technology to apply it to a field and better something. This year our field is the ocean. Someone did research and found out that there are gyres in the oceans that are like whirlpools, and they pull in all of this plastic and all of this garbage that pollutes our oceans. So this year our goal is to remove all of the waste from these gyres, as well as take any wildlife that may have gotten caught up and caught in this pollution and help save those with our robots.
Is this your robot?
Yes, ma'am. This year's robot is named Aquarius, and it will ride along the currents. As you can see, our PVC square ray here. This allows it to glide through the currents and stay balanced. We also have an arm and gripper. This allows us to reach multiple gyres throughout the oceans at different areas and collect trash as well as wildlife. If you would like to root on our team and cheer us on to victory and see Aquarius in action, come down to Thomasville High School's gym at 9 o'clock this Saturday, October 20th, to watch.
Are you going to tell us about your company?
Yes, ma'am. Our company has a marketing department. This marketing department helps us broadcast and get sponsorships for our team. So our team is set up with, of course, a CEO and 6 departments. Our departments have a department head, so we have documentation, spirit and sportsmanship, programming, engineering and design, marketing, and exhibit booth. Each of these has someone over it, and then we have anyone who would like to underneath each category to help. Some people like to help under multiple categories because they can multitask. So over our documentation is Lizzie Fairclough. We have Javion Young and Jamarcus Rowden over spirit and sportsmanship. Paul Grammer-Spocker is over programming, which is mostly his CNC, and I work with the programming of the robot. We have our engineering and design heads are Jason Dong and Will Vick. Marketing is Ashantis Arnold, and the exhibit booth is Madison Barnes. We would like to state that our company, compared to others, is more efficient, passionate, and hardworking. So along with this, we try to make sure we have a diverse environment. It's very well explained for our community. So our ethnicity is 8% Asian, 25% African American, 58% Caucasian, and 8% biracial. This really does exemplify our community, as I've stated. Now, the male to female ratio is not. There are more males in the engineering field. For some reason, everything is always got, oh, well, that's just for guys. Oh, well, this is just for girls. Here at Tiger Tech, we're trying to make sure everyone knows that it's not just for guys. Girls are totally welcome and can most of the time do a really great job. We have multiple areas of experience. Most of our team has had 4 years or more in Best Robotics. Other than that, we've got a few that are 3 years, and then some, this is their first year. Our grades are almost evenly spaced out. We've got mostly 10th graders, or 9th graders actually, my bad. A few seniors, a few juniors, and, well, more juniors actually, and then a few sophomores. Most of our team is interested into going into the STEM field. In fact, BEST has impacted a lot of our people to go into STEAM rather than other fields. I myself had planned on doing culinary arts and have swapped to doing software engineering thanks to BEST. Our team boasts proudly we are all 100% college-minded. Of course, none of this is possible without a budget. So we explain our budget, where we started, how much we've gained through sponsorships, our expenses along the way, and our total income overall. So to start off, we have to define the problem. This year, as we mentioned, is the ocean. So how are we going to get the trash out of the ocean? How are we going to rescue the turtles? And how can we remove the ducks so that we can figure out the current flow analysis so that we can know where to go? After this, we have to generate ideas on how to do so. So we brainstorm, we present it to our group, and then we all vote on it. Next, we develop a solution. So we take all of those ideas and we put them in a decision matrix. So this lets us know which idea we need to go with, or which scoring strategy we need to take on that would give us the most points and help us get the farthest in the competition. After this, we begin constructing prototypes of these and decide, yes, this works, no, it doesn't, or it might work, but it needs a little help. Then we evaluate, okay, is that efficient? Can we improve it anymore? Is it necessary? Should we just go ahead and get rid of it, or will it be reliable? A lot of this is done through our CNC machine. Once we've created our prototypes, we go in our CNC machine, create our programs, and put them in our computer, which then the CNC machine will cut. This is our CNC specialist, Paul Grammel-Spocker. Other than that, we have programming the robot. So once we have parts of the robot, we have to program it to work together. Our team does specialty programming, so we'll specialize the robot functions or the control locations. If someone is more right-handed, we'll consider everything on the right hand of a controller rather than spread out everywhere. We meet all of the requirements of our engineering team, and then we have to go to hardware. So you take your motors and you solder wires to make connections from there to interface cables through 2-wire screw terminals, and then we connect that to our brain of the robot. We also do this with servos, but they're less complex. You just connect them to a servo adapter and, if need be, an extension. These are our connections throughout, and then we have our base code. We use our base code for everything we do. We update it each year, so if something changes in Robot C and you need a new type of program or new line of program, we add it to our base code. That way we can just pull from it and get what we need. That leads us to this year's program. This year's program doesn't have as many trial and errors or testing and debugging per se. A lot of it was done through our base program, so that helps us move along quickly and efficiently. So we go through our program and we have where our pivot joint moves, our wheel moves. This allows us to move up and down the current. It also allows our arm to rotate side to side to get multiple gyres. Then we have the main arm moving up and down, the secondary arm moving up and down, and our claws opening and closing simultaneously. That way you don't have a glitch and one opens while the other one closes, and so forth. Same thing with our cargo disposal, which is still in progress with the engineering team. That being said, this year's slogan is S.O.S. We're trying to save our seas with this year's product, Aquarius. It is focusing on cleaning up the ocean and wildlife rescue. This is a benefit for our Earth because 70% of the Earth is composed of ocean. That 70% is polluted with 8 million megatons of plastic. So our robot is specifically designed to target that. We also, other than just saving the ocean by taking out the trash and helping the wildlife, we take that and we create those into reefs that will actually help our ocean grow. We have got multiple outlets of outreach. We have gone through our school and put posters in multiple places. We reach like 90% of our students. We've announced over the intercom, we are here with you today. And we also have social media accounts like Facebook and Instagram. We have a Twitter, but I think the confusion of our numbers being changed has led people to unfollow us, or they just haven't gotten to our new account. So we invite everyone to. This we plan on adding to. We're going to try and meet with the Boy Scouts of America, go to the Boys and Girls Club, and meet with other classes in our school. And if possible, we would like anyone to invest in us. If they like our product, if they would like to sponsor us, we also invite them to do so. You have our email, and we can send you any forms you would like. If you need more information on programming, we have an explanation. We also have an engineering notebook which walks you through everything that we did for this process. if there's any questions you have, Miss Deborah.
Well, first of all, I want to thank you for doing such an outstanding job explaining your company and your role in this Saturday's upcoming, is it robotics?
Robotics.
Best robotics competition. Tiger Tales is your name of your group, right?
Tiger Tech.
Uh-oh, look at me. Where did I get Tiger Tales from? Okay. So Tiger Tech is the name of your program here at Thomasville High School.
Yes, ma'am.
Give us the name of your company again.
Our company is Tiger Tech.
Okay, now Tiger Tech, now what is is it game or the slogan that you have this year?
Our slogan this year is S.O.S, which stands for Save Our Seas.
Thank you. That's what S.O.S. How did you come about that again?
Just our brainstorming with our marketing department. We went through multiple ideas, and this is the one that really stood out because we're saving our seas. S.O.S stands for help, so we found an acronym that would work with that.
Very good. Well, thank you so much. Now, who else will we be speaking with today?
We will be speaking with Jason Dong, which is over engineering and design. If you would like, I can go further into programming. Lizzie works on our documentation, and I believe that's it. We may speak with Paul on CNC.
Okay, very good. Thank you so much. And we'll come back with you to wrap it up.
I'm Lizzie Faircloth, and I am the head of documentation here at the Tiger Tech company. What I do essentially is I document everything we've done throughout the whole process. We start off with safety because safety is the top priority of the team. What we do for that is we make everybody on the team take a test, which the test looks similar to this. And if you do not make 100% proficiency on it, then you cannot help the team. You do get multiple chances, but till then you cannot help. And we do have safety rules. If they are posted in the corner, laminated, and we have caution tape marking off where you need to start wearing goggles at. Anybody who does not have goggles and the appropriate attire cannot go and work with the machines. The main part of the engineering notebook is the engineering design process. Through it, we first have to define the problem, which means we have to take into account all the constraints we have, such as the robot can't be no larger than 2 feet by 2 feet. And we also have a limited amount of items, and certain items we can and cannot use on the robot. For example, this year we cannot use piano wire, but we can use coat hangers in its place. After we define the problem and everything, we go to generating our concepts. We first start out by figuring out what our scoring strategy will be. In this case, our top priority is getting the garbage, because with the surplus amount of it, we can get the most points the fastest that way. We only have 3 minutes to each round, so points are important. Then, once we figure out what our scoring strategy is, we go into making concept sketches. For example, this one is for the wheel design and the scoop or claw. Then we will go into more, such as an arms, different ideas, and some people will even put a whole robot together. Once we do all this and decide what we're going to start with, we'll do some calculations to figure out, will it actually work. This calculation is for torque, for the gear system on the arm, and whether or not small motors will work. We also use the circumference formula to figure out the best size for the wheel, because once you know the circumference, you can figure out how far it will travel. We also design and generate concepts the cargo disposal, which is used to put garbage in, and the programmers will make it where it can tilt and it'll slide into the box wherever needed. We also use decision matrices to figure out what type of material will be needed. For example, for the cargo box, we decided that cardboard would be the best because it has the best use of the servos. It's not overly complex to build, and it will be fast, and the materials will be readily available. Next, we go to developing a solution. This is where we will start actually drawing specifics and figuring out the dimensions. We have sketches for stuff such as the planetary gear, which I do not have on here right now. After that, we go into construct and test prototypes. This is where we will make them out of cardboard and then use human hands in the place of motors and servos to see if it'll work. If it works like that, then they'll go into making it out of wood. For example, our first wheel design, planetary wheel, looked like this. It turned out not to work when it was put to the test with an actual motor because the gears would get stuck on each other and wouldn't allow it to turn. After several modifications, we decided to go with a simple wheel with bicycle inner tube to help grip the ocean current. Once we're done testing our prototypes, we'll go to evaluate the solution. We got to evaluate it on practice day with mall day, as they call it. Our robot, we were extremely pleased with. The only problem we had was the small motor would, because of the weight of the arm, would pull down. So to fix that, we have put in place rubber bands to keep it from pulling down too far, and this to make sure it doesn't either. We did this because if the motor keeps getting pulled down, it'll cause the motor to burn out. We are planning to present our solution at hopefully if we make it to the regionals and here at our local hub October 20th. Once we're done with the engineering design process, we go to the research paper. The research paper is to see what we can learn from it. For example, we start out with the history, such as, in this case, the history of recycling and when it started. I found out it actually started around 400 BC in ancient Greece, and it was known because there was a significant decrease in broken vases and tools during that time. Over the years, there was periods where recycling wasn't that common, but in the 1970s is when it changed. That was the time when Earth Day came out and people started realizing we need to recycle more. Plastics mainly, because by the 1970s they had made non-biodegradable plastic and they noticed it was filling up our landfills. And now when we move on from history, we go into the technology, and nowadays some of the most interesting stuff we found was the C-bin, which is a filtration system made from a pump, a bucket, and netting. All you do is put it right near where you would have a dock, and it would filter out any waste, such as plastic, from the top of the water, which will help keep it out of the dryers. There is one company, the Ocean Cleanup, actually have started working on cleaning out the dryers. They have a U-shaped net that flows with the current and will collect it. They plan by 5 years 50% of the plastics in the Great Pacific Gyre will be gone. Once we're done with the research paper, we go into our appendices, which has team demographics in both table and graph form. Then we go to our team mentors, which we have 10 this year. Then we also have the corporate structure set up. After that, we go into our meeting minutes, which is what I have to take every day after a meeting to know what each department did. For example, October 13th, after Mall Day, the engineering department started working on fixing their cargo box. The marketing team started working on the marketing presentation. And I was finishing up writing any meeting minutes I did not get to at the time. After the meeting minutes are finished, we go to our scoring strategies. This is a more in-depth version of it. As you can see, our first one, the plan is to score 1,335 points. And to do that, we will need to get a total of 6 soup cans and install one of them, reef blocks, 8-ounce bottles, collect 4 of them and complete the reef block, and get 5 16-ounce bottles and install the reef block that can be made from them. And we also plan to get a flexibility bonus and current flow. Current flow is where the rubber duckies that sit on top of the current, you use them to see what the current's going to be like. For example, it has a certain number, like if you're at green, it'll be 3 green, and you need all 4 of them to get the correct one. And the greatest chance without all 4 is a 50% chance, and that is if you know 2 of them. If you know 3, then if you know the other 3, then you're gonna guess it. Our second score strategy is a lot less. It is 1,075. In this case, we don't install but 1 reef block, and we only get the current flow bonus because we guessed right. The turtles, which are in it, actually are 3D printed, about roughly this big, and on the inside there's a cap, and you take it off and there will be a picture of whichever garbage it is, whether it be soup cans, bottles, microplastics, and whichever one, you get double points for that specific one. This is one of the and then we go to concept sketches. This is one of the concept sketches. This is for the chassis or the body of the robot. Those are the wheels, and this would be where the current would be. After that, we would go into programming, which Maggie could explain better than me. All it does is explain what was done, the design behind it, the coding and verification, the testing and debugging, in relation to scoring strategies. After all this, there is a section for our national registry. What it is everybody registers. Well, Ms. Baker registers us, and we get our information, grade level, and age. After that's done, ours is turned in the earliest. The engineering notebook must be turned in roughly a week earlier than everything else. That's because how long it takes to read over it. Jason Dong, the head of engineering, can explain more in depth the thoughts behind it. Any questions, Ms. Deborah?
So how long have you been serving in your capacity, and how rewarding is it for you?
I've been on the robotics in this company for roughly 2 years now, And I've been head for, this is my second year being head of documentation. I do fairly well. I mean, every now and then it gets a little hectic the closer it is, and the less you have done, the more you have to rush, which can compromise the English and language that you use within it. Because this has to be very formal writing, very scientific. Can't use slang terms such as ain't, or you use stuff such as you, I, me.
Well, very good. I want to say congratulations on a great job. So good to see you again, Lizzie.
Thank you.
Hi, I'm Paul Gramelsbacher. I am the CNC specialist of Tiger Tech 2110. And I run our CNC machine. We just got this last year, so it's fairly new to the team. I'm the first person to know how to run it. So I'm just here to answer any questions you might have about the machine.
Well, why don't you tell us about the machine and your role in this project this upcoming Saturday?
The project obviously is the robot that we have to build, and a lot of the components on the robot need to be very specific in their size and shape, right? One of those parts is a gear, right? Our robot has like almost 4 gears on it, and they need to be precisely cut so that they'll fit together and mesh and work the way we want them to. And that's just simply not possible with the kind of manual tools we have. So we have a CNC machine that can do that for us, right? So we just put our piece of material here, maybe 1/4 inch plywood, glue on, whatever, and then you clamp it down, cut it out, right? So I code on that computer, I design something, and first I make it into a 2D sketch, right? So I draw maybe a square, maybe a circle, maybe a gear, right? So then I move it into another software where I add depth to that 2D shape. And then once I've added depth to that 2D shape, make it 3D, I upload it to the CNC machine, make it run, and it cuts out the pattern that I've programmed into it. That is the basic process of how the CNC machine works. And that's the reason it's so important to our team, because we use gears in a lot of our designs. And it's just more efficient, and there's a thing called gear ratios where you can make things have more torque or more speed. So that's very, very important if we're going to incorporate that into our robot design.
So, do you mind telling us how long you've been working with the CNC machine, and also how long you've been a part of this robotics team?
I've been working with this CNC machine. This is my second year working with the machine, and this is my second year on the team. Last year when I was the first year I was on the team, they didn't have anybody who knew how to do this, and everybody else was kind of taken because they had jobs they had like been set into. So I was the only person that didn't have a role, so I took up this role. So as long as I've been on the team, I've been the CNC specialist.
Very good. Is there anything else you would like to add?
No, ma'am.
Well, thank you so much. Great meeting you, and keep doing what you do.
Yes, ma'am.
Alright, so my name is Jason, and I am from the team 2110 at Thomasville High School. I'm the lead engineer, and I am the one that orchestrates everybody on how they construct the robot. Here we have a few, you can see that we have a few designs in two-dimensional. This is a extender, a rotary to linear motion device, and here is a prototype of it. The way this would work is that when the wheel spins, this shaft would elongate. And we thought about using this for the arm, but we decided not to use this idea. Here you can see a claw design, which is more of a shovel than an actual claw. Here are some wheel designs, and a whole engineering notebook full of other designs. As you can see on the robot here, this is our completed model. We used mostly wood to construct this because wood was durable and for the most part it was lightweight. And we used gears cut from the CNC machine, pulley mechanisms, and we used this thing, which is bicycle inner tube. We glued each end together so it was smaller than the diameter of the wheel. Then we stretched it over the wheel, and basically it fit like a glove. That's why it's so tight right here. And this wheel is the main motor that controls the robot and moves it up and down the beam. Would you like a demonstration?
We would love one.
This robot is constructed in two parts. If you pull these pins here and take them out, this robot can be taken apart from a bottom half and a top half. That's what keeps the robot from falling off the beam.
Very good. So, tell me about your experience as being the chief designer of this project.
Well, I started robotics when I was in 8th grade, and ever since then I've fallen in love with it. I love robotics, and this year it was no different. As a chief designer, I felt like I had more say in what went into the robot, and as you can see, a fair bit of that was my idea, but the team also contributed a lot to it. So I would say all in all, I've had a pretty positive experience with robotics.
Thank you so much. Appreciate that. Great job.
Thank you guys for coming and visiting our equipment area, our labs, everything, and just finding out what our team is about. We hope you would like to invest in us. If you would, contact us at the email we gave you earlier. We'd also like to re-invite everyone to our competition this Saturday, October 20th in the Thomasville High School gym at 10 o'clock. Opening ceremony actually starts at 9.
Thank you so much, and I just want to say that it has truly been a learning experience, a joy, and just a fantastic time spending time with your team and your company. Thank you so much for the invitation.